The frame opens in near silence. New official portraits of three, eye divided by atlas, hang against a clean black. A pale coma, a needle tail, and hair-thin jets stitched across the dark. It looks implausible at first glance, yet every line can be drawn with sunlight, volatile ice, and micron-scale dust moving at interstellar speeds. Angles begin to rotate. A montage flips between viewpoints so the tail seems to bend, jets shift, and brightness skews along invisible axes. Nothing requires the supernatural. Perspective, phase angle, grain size, and the solar wind can turn a drifting nucleus into calligraphy. What reads as spectacle is geometry written at astronomical scale. Context tightens the focus. Only 2 interstellar visitors have been seen before. This is the third. Rarity amplifies the impression, but not the claim. The images exist because of long exposures, calibration frames, and patient cross-checks that make surprise measurable. Hard to believe is permitted. Repeatable is the standard that follows. This episode sets its contract in plain language. It will show what the frames actually record, how such frames are made, and what conclusions survive methodical tests. Facts and methods will steer every claim. If an anomaly holds up, it will be named. If the data stay quiet, that quiet will count. Wonder is welcome on the same bench as evidence. Interstellar visitors were once a classroom aside. Year 2017 brought the first that only passed through. Then year 2019 delivered a second that behaved like a textbook comet. A third now crosses the ledger. The sample is tiny but decisive. The galaxy sheds fragments, and when they stray into sunlight, they write their biographies in dust, gas, and changing light. From find to fact is a narrow corridor. Wide field surveys image the same sky, night after night, hunting motions that refuse a bound ellipse. Candidate tracks are fit to hyperbolic solutions. Uncertainties shrink with each added night. If excess speed persists and the curve won't close, the verdict is interstellar. No tether to the sun, no repeat, velocity beyond escape. Seeing is a moving target. Apparent brightness slides with distance and phase angle. The atmosphere smears the point spread. Filters choose which photons survive. Some nights yield only a fattened point. Others resolve a coma with a hint of a tail. Longer exposures raise signal and also artifacts. Every frame is a negotiated truce between what is present and what the method can reliably keep. Official images are not a crown. They are a method trail. Captions list telescope, timestamp, filter, exposure, and calibrations bias, dark, flat. So, another team can rebuild the contours within noise. Space agencies and major observatories release them to privilege replication over rhetoric. Wonder is invited, but auditability gets the front row. The first 2 visitors taught restraint. One looked geometrically odd and fueled arguments about shape and composition. The other mirrored inner system comets and reset expectations toward the ordinary. Together they bracket interpretation. If a newcomer follows known comet physics, sublimation with solar distance, jets modulated by rotation, dust, colors, and polarization within familiar families. The null model is natural. Geometry writes illusions that taste like paradox. At small phase angles, dust sheets in the orbital plane can project as a sunward spike, an anti-tail that seems to disobey the Sunday grain size, steers color and polarization. Rotation exposes and hides active vents, turning jets on and off across hours. What the eye names unbelievable is often perspective and particle physics drawing with its left hand. This is why the current images matter. They do more than look sharp. They sample different lines of sight with different instruments, converting spectacle into constraints. Together they sketch a working system, a spinning nucleus, ices that lift into gas, dust sorted by size and sunlight. The task that follows is plain but demanding: read what is written and refuse to add words the sky did not supply. A single update changed posture into procedure. The newest official frames of 3, I divided by Atlas, arrived with disciplined captions, matched processing, and enough angular spread to move discussion from impressions to tests. Jets ceased to be artifacts of aggressive contrast. They gained coordinates, profiles, and timestamps. That shift from rumor to resolvable feature is the ignition event that organizes this episode. Objective 1. Read images as measurements, not illustrations. Each frame encodes geometry, sun, comet, observer lines, phase angle, and projection that can turn a thin dust sheet into a sunward spike. The task is to rebuild the three-dimensional scene from two-dimensional hints and ask what remains once perspective, stretch, and point spread are accounted for. What survives that audit earns acclaim. Objective 2. Compare without mythologizing Interstellar. If behavior is comet-like, it should trace familiar rules. Sublimation rises with solar heating, discrete vents modulate jets with rotation, and grain sizes reveal themselves in color and polarization. Matching those baselines is not a demotion, it is mechanism. Only deviations that withstand method deserve elevation to anomaly. Objective 3. Filter noise at the speed of rumor. Popular narratives outrun calibrations. This program will list the common claims and grade them against evidence. Spectra that do or do not show expected bands, light curves that favor a rotation period or a tumble, and resolved structure that either demands engineered edges or dissolves under alternative stretches. Each assertion carries its burden. Methods are declared at the door. For imaging, instrument, filter, exposure, sky, background, bias divided by dark divided by flat, registration, cosmic ray handling, and any deconvolution with kernel and iteration count. For photometry, apertures, 0 points, seeing, and stability tests. For spectroscopy, bandpass, resolution, S divided by N, and removal of telluric lines. For polarization, angles, wavelength, and calibration, stars. Without these bones, posture is not science. Anomalies require names and ladders. Examples include a jet brightening faster than thermal models allow, a color slope outside common dust families, a linear feature that resists projection geometry, or a gas ratio that strays beyond solar system ranges. Each class gets candidate explanations ranked by parsimony. Extraordinary begins where ordinary models stop converging under honest error bars. Scope and limits keep shape. The observing window is short, brightness evolves quickly, and instrument time is finite. This analysis will not adjudicate claims that exceed data or lean on single stretch imagery. It will also not confuse caution with dismissal. Wonder is permitted to sit in the room on a chair labeled subject to revision and facing the lab bench. The working pact is simple. Measure first, compare second, filter third. If a feature persists across methods and epochs, it enters the record. If it fades under stricter reduction, it becomes instruction, not intrigue. The ignition event supplied the spark. The objectives supply guardrails. Between them lies the work, transparent, incremental, and ready to move when better light arrives. Early images arrived as disciplined hints. The target was faint, seeing was average, and exposures erred on caution. Photometric points ticked upward with falling heliocentric distance, yet structure hid inside noise. Teams logged filters, sky, background, and tracking, then stacked sparingly. A shy coma emerged, measurable, repeatable, not yet willing to reveal shape. Ground facilities lengthened the reach, longer integrations and redder bands boosted dust continuum while keeping common gas lines in view. Point spread asymmetries from wind and tracking were anchored by calibration stars. Aperture tests proved stable across nights. With each pass, the profile drifted from stellar to cometary, trading speculation for contour. A weather gap yielded a clean run. The coma's surface brightness slope steepened, and a faint elongation held across frames. Persistence turned suggestion into feature. Concentric aperture photometry located the radius where dust dominated. The light curve, once jittered by noise, settled enough to hint at rotational modulation, with aliasing still on the table. Resolution sharpened questions. Better seeing and bounded deconvolution exposed a pencil-thin extension on the sunward side. It survived field rotation, repeated in multiple filters, and tracked expected solar geometry. The working tag became Jet A, logged in comet-centric coordinates with position angle, length scale, and surface brightness profile recorded. Confirmation arrived by disagreement. A second observatory with different optics and latitude repeated the geometry the following night. Jet A reappeared at a rotated aspect consistent with nucleus spin. Profiles along the feature supported a collimated dust outflow rather than a trailed star or cosmic ray. Background sources were mapped and ruled out. The ledger accepted the entry. Downstream, a paradox teased the eye. A narrow spine seemed to point sunward. Projection solved the riddle. Dust sheets laid in the orbital plane can, at small phase angles, project as an anti-tail. Model overlays matched the viewing geometry, turning misread spectacle into geometry in plain clothes, with uncertainties disclosed in captions. Spectra added chemistry to shape. Moderate resolution searched for familiar radicals, while continuum slopes traced grain sizes. Signal to noise was uneven, but trends matched warming ice, gas signatures strengthened toward perihelion, and dust colors reddened as larger grains took the stage. No line compelled the departure from comet physics already on the table. Polarimetry translated light into texture. Degree and angle of polarization rose with phase in patterns familiar from porous aggregates. Slices through Jet A showed small, consistent offsets from coma averages compatible with size sorting rather than surface coating. The maps were coarse, but the direction was coherent. Jets differed subtly in how they scattered sunlight. Rotation entered through cadence. Short time series photometry carved the shallow periodicity out of noise. Period families converged on hours, not minutes. Folding the data-aligned jet position angle drifts with candidate phases. The nucleus did not tumble chaotically. It turned with enough regularity to gate vent activity and modulate brightness on humanly trackable timescales. The anomaly stack began with speed. On one sequence, Jet A brightened rapidly and relaxed within a single night. Rise times pinched, simple thermal inertia models. Candidates ranked by parsimony, a facet rotating into direct sunlight, a brief crustal failure exposing fresher ice, or a transient grain size shift in the flow. The tag A1 entered with test queued. Color wrote the second entry. A narrow arc downwind displayed a flatter spectral slope than its surroundings. Pipelines were rerun to chase filter, mismatch, flats, and sky color. The signal persisted at low significance. Two possibilities led: larger grains settling toward the midplane, or a gas-rich filament, washing out dust reddening. It parked as A2, awaiting deeper sweeps. Geometry supplied a third puzzle, then demoted it. Far from perihelion, the tail spine kinked slightly from the anti-solar line. Dust should lag solar wind whims, but a weak ion contribution in one band could bend the feature. Cross-checks found support, and the entry stepped down from anomaly to bookkeeping, a reminder to label bands carefully in public frames. Method fenced emotion at every step. Bias, dark, and flat calibrations rode with each night. Deconvolution, when used, listed kernel width and iteration count. Registration quoted residuals against field stars. Stretch functions were disclosed so contrast would not impersonate edges. Dull transparency was the goal. Less drama, more replication. Comparative context kept scale honest. Panels placed the visitor beside a well-studied inter-system comet and the previous interstellar case. Morphology fell on a continuum. Jets, anti-tail projections, and color slopes had precedence. The novelty was not type but vantage, a third data point from beyond the sun's family, viewed with modern cadence and polarimetry. Silence tallied as carefully as features. No polygonal edges stabilized across filters. No periodicities beyond spin survived scrutiny. Spectra stayed within chemistries, negotiable by cold ices and hot sunlight. Absences were not afterthoughts. They were constraints with numbers, upper limits that future instruments must beat if they wish to move the needle. The working picture tightened around a modest nucleus with discrete vents. As rotation swept facets through sunlight, jets brightened and paled. Grain sizes evolved with geometry, shifting color and polarization maps. Projection sculpted anti-tail illusions at specific phase angles. Within current uncertainties, the ensemble pointed to comet physics with no need for special pleading. Cost stayed visible. The window narrowed as brightness waned. Competing programs pressed on the same facilities. Weather added random punctuation. Exposure budgets were triaged toward sequences that retired the largest uncertainties. Locking rotation families, testing the persistence of Jet A, and chasing the low significance color flattening flagged as A2. A1 and A2 earned targeted plans. Repeat imaging tracked whether the rapid brightening recurred at fixed rotation phase, favoring event geometry over a stochastic burst. Multiband arcs probed if the flatter slope stayed welded to the midplane or wandered with viewing geometry. A negative result remained valuable. It collapses parameter space and cleans the model. Spectral follow-ups kept ambition realistic. Deep integrations at bands where prior hints lived offered either a closure on gas ratios or tighter ceilings. Telluric removal and standard star routines were spelled out to preempt copy and paste skepticism. Non-detections would still be publication worthy as brackets on chemistry, not as empty pages. Polarimetry requested one more angle. A late phase map could separate grain families with cleaner contrast and test whether jet offsets persisted or blended back into coma averages. Even null changes would sharpen grain models, feeding into dust dynamics that set how anti-tails sculpt themselves in projection. By the final night in the sequence, images read as sentences rather than syllables. The tail no longer seemed to defy the sun. Particle size and viewing geometry explained its posture. Jet A was not rumor, but a timed vent with a documented profile. The anomaly stack thinned to two candidates, both natural until stronger evidence moved them. What could not yet be claimed stayed outside the fence. Nucleus shape remained unresolved, mass and density were model dependent, and deeper chemistry waited on brighter lines or larger mirrors. Those limits did not weaken the narrative, they bounded it. Inside the boundary, behavior matched a comet crossing another star's weather. The camera drew back without closing the book. The traveler kept moving. Data hardened into parameters. Parameters assembled into a cautious story. The plan that followed was modest, testable, and time-boxed. If later light revises any page, the same methods that built this record will retire or replace it. For now, the ledger reads, jets, projection, dust physics, remarkable in vantage, ordinary in cause. The record opens with what refused to appear. Spectra showed only the chemistry that sunlight and common ices negotiate. Faint radicals near detection, continuum where dust dominates, and nothing that would force exotic interpretation. Upper limits were written beside each non-line ceiling set by exposure time, instrument throughput, sky background, and the noise that careful subtraction could not erase. Images contributed a disciplined quiet. Hard edges that might hint at machine planes, never stabilized across filters or nights. Linear features dissolved under alternate stretches. Polygonal silhouettes failed registration checks against field stars. Deconvolution logs, kernel width, iteration count, residuals sat in the captions like ledger lines. When a feature exists only under one stretch, method files it as provisional, not probative. Timing added negative space. Light curves folded over candidate periods yielded families of spin solutions in hours with no surplus power at frequencies unrelated to rotation. If a beacon were present, its duty cycle, amplitude, or wavelength hid outside sampled bands and cadences. Silence here does not prove absence. It narrows the corridors where any engineered modulation could still live. Polarization maps answered softly. Degree and angle varied with phase in patterns familiar from porous aggregates, not from specular engineered surfaces. Offsets along the jet were small and consistent with size sorting, not coatings. Error bars mattered more than means. Within uncertainties, the data declined to demand new physics. That refusal is information. It trims the model's space to the ordinary first. Together, these negatives shape a boundary. They do not end debate, they sculpt it. Hypotheses that need strong exotic lines, rigid edges, or technoperiodicities must explain why those signatures remain under measured limits. Non-detections become constraints, not shrugs. In this ledger, silence is not a blank. It is a ruler laid against the sky, marking where claims cannot stand and where natural comet physics still fits. The working frame is straightforward. The visitor behaves like an active comet. Sunlight warms volatiles, discrete vents lift dust, and a tail forms under solar geometry. The new official imagery stuns because vantage is rare and cadence is dense, not because the physics is unfamiliar. Interstellar widens context without suspending the rulebook that ordinary comets already obey. Provisional means tethered to measurements. Jets are now resolved features with positions and profiles. Anti-tail appearance tracks, known projection effects at specific phase angles, color and polarization sit within families mapped in the inner system. Each point survives reduction choices and cross-checks. Where fits loosen, the language changes from claim to candidate and remains there. Important unknowns still set the contour. Nucleus shape lies below resolution. Density and strength are model dependent. Gas ratios carry wide bars when signal thins. Rotation solutions cluster but retain aliases. These are not afterthoughts, but debts payable only with longer baselines, deeper integrations, and geometry that turns the scene enough to break degeneracies. The first cost is the calendar. Brightness falls as the object recedes. Windows close by celestial mechanics, not by preference. Observatory schedules are written months ahead, and weather edits them without appeal. Lost hours do not just trim pictures. They widen uncertainties, forcing triage on which questions can still be closed before the door shuts. The second cost is hardware scarcity. High stability spectrographs, crisp imagers, and polarimeters are few in orbit and on mountaintops. Time on them includes calibration that does not show in highlight reals, darks, flats, standards, telluric removal, and rejected frames. Pipelines need tuning to target, not copy-paste. Precision lives in this unglamorous ledger. There is also a cost in attention. Narratives move faster than calibrations, and corrections rarely travel as far as the rumor they amend. Communicating limits, filters, stretches, thresholds is slow work that resists virality. Yet only that work turns spectacle into constraints others can reproduce. The episode treats method sections as payload, not packaging. Conclusions follow a narrow rule. Adopt the simplest model that explains the data and keep a door open where the fit strains. For 3, I divided by Atlas, standard Comet physics accounts for jets, tail posture, color slopes, and polarization maps without exceptional premises. Earlier, anomalies shrink under geometry, cadence, or low significance color changes awaiting deeper light. Opportunity costs shape what happens next. A denser cadence might lock a rotation period. A deeper spectral sweep might close chemistry. A polarimetric pass at a new phase angle could separate grain families. Each choice trades one closure for another. The plan names these forks so the record shows why one uncertainty tightened while another remained. The forward program stays modest and testable. Acquire bracketed images across phase angles to confirm anti-tail projections. Run multi-night photometry to collapse rotation families to a single period. Target spectral bands where past hints appeared, accepting that non-detections still lower ceilings. Publish reductions with processing bones exposed so independent teams can rebuild the result. None of this excludes wonder. It seats wonder beside evidence and gives both a role. The images feel unbelievable at first because the eye loves straight lines and the sky writes in projection. Interstellar distance adds romance. Instruments remove fantasy. What remains is stranger than rumor and kinder to truth. A comet writing legible physics in borrowed sunlight. So the resolution stands where science usually stands, firm within data, cautious at the edges, and ready to move when better light arrives. If new observations overturn a page, the same method that built this frame will retire it. For now, the ledger reads clearly enough. Jets gated by rotation, projection, sculpting tails, dust scattering that matches precedent, remarkable in vantage, ordinary in cause. The sky keeps its own schedule. As the visitor drifts outward, brightness will fall and structure will soften, yet geometry will still turn the scene. A narrow window remains where changing phase angles can test anti-tail projections and watch jets dilute into background. The goal is no longer spectacle, but closure, small, well-posed measurements that tighten the model rather than enlarge the mythology. 3 tracks lead the program. First, bracketed imaging across phase angles to check whether the sunward spike collapses exactly as projection predicts. Second, multi-night time series photometry to squeeze rotation families until a single period survives alias test. Third, a disciplined spectral sweep at bands where faint gas once flirted with detection, accepting that another upper limit still sharpens chemistry. Polarimetry earns one deliberate return. A map at a new phase angle can separate grain families with cleaner contrast and test whether jet offsets persist or blend back into coma averages. Even a null result is not empty. Silence reduces parameter space with the same authority as a signal. Dust models profit either way by confirmation or by the tightening of bounds. Coordination multiplies power. Modest apertures can carry cadence while larger mirrors anchor depth. Shared calibrations, flats, standards, and reduction notes turn scattered observatories into a single method with many telescopes. Consistency is the instrument here. Identical pipelines across sites make replication routine and misreadings brief. Communication remains part of the physics. Releasing reduced frames with filters, exposure, and stretch named in captions preempts shapeshifting claims. When rumor says the tail disobeys the sun, the quickest correction is a figure that others can rebuild. Error's half-life shortens when methods travel with images and debate retreats to where it belongs inside uncertainties. Expectations should be plain. A rotation period tied down to hours rather than families. An anti-tail that behaves as geometry demands. Spectra that either close the gas ratio or lower ceilings for future instruments. Polarization that nudges grain models instead of overturning them. None of these deliver fireworks. All of them convert a rare pass into a reusable datum. The reflection is quieter than headlines. Interstellar distance was the hook. Ordinary physics is the lesson. A third traveler chose familiar behavior, ice warmed, dust lifted, light scattered, and images that felt hard to believe learned to speak in numbers. Wonder did not leave. It took a seat beside evidence and waited for the next window, where the same rules will write the next page.